Welcome back, everybody. It's been a couple days, and I'm at the Harrisonburg office, and Paul is at another location. We have processed our scans, and today we're going to look at what we can do on an iPad, as well as downloading the data from the cloud and inspecting it on a computer.
Yeah, so let's go ahead and start out with actually looking at what we did with the project that we left off with inside of Artec Cloud. So I'm currently on my iPad right now. So I've got Artec Cloud pulled up on my iPad here, and you can see that we've completed processing out the section of rail here. And we also went ahead and added a texture map to it so we can see all the individual colors. And we've got our fully completed mesh here. So from this point, it's very straightforward to be able to take this and download it as an STL mesh to work with from either inspection or reverse engineering here on our iPad. We can simply just come in and tell the software that we want to export models, and we can pick this particular Sharp Fusion, and we can change the format. So we'll pull it down as an STL, and then we can press export. Once we press export, we'll go ahead and have our model processed and downloaded. You can see we've got a download right now. So once we've gone through and downloaded the scan file from Artec Cloud, we have that STL mesh right here on our iPad and our Files app. So I can take this and work with it in a few different softwares. The software that we're going to play around with today is called Shaper 3D. So we can just go ahead and take this file right here, import it into Shaper 3D, and then go ahead and start working on turning the STL mesh data into a CAD section of that rail. So now we've got this section of rail here inside of a software called Shaper 3D. This is a pretty interesting software because we can import STL meshes, and we can reverse engineer those meshes all directly on my iPad. So keeping with the theme of trying to see how far we can work with the data that we're used to working with on Windows-based machines, how far can we take that process on something like an iPad, for instance? So with a software like Shaper 3D, we can still bring that file in. We can align it into a coordinate system and get it all trued into a position. And then from there, we can start building out the raw geometry of our file. So we've got a little bit of fine tuning here that we're doing just to make sure that everything's exactly lined up where we want it to be. And now we can actually start sketching out geometry. So one of my findings is this type of software, as opposed to, say, using a plugin inside of SOLIDWORKS or DesignX or using the tools that are in Artec Studio, we do have to just change the way that we do our reverse engineering ever so slightly. So Shaper 3D is really built around building out solid objects and extruding those into, or building out 2D profiles rather, and then pulling them into solid objects, and then pushing and pulling and manipulating those for various geometry creation, as well as using those solid objects as sketch profiles. So while we can go in and create accurate 3-point planes inside of this software as well, what I found was if we just build out one simple solid body initially, we can use that as our reference point to be able to more easily sketch on our part and keep everything true in a CAD fashion.
I'll just jump in here and say that, of course, Artec Cloud allows us to take our models and also pre-align them to a coordinate system that makes sense. So the tools that are available in Artec Studio can be more precise depending on your object. And then when you have it imported into this app, it's already aligned, so there wouldn't be any need for further alignment.
Sure. Yeah, no, exactly. But it's nice to know that you have these tools in case you need to reorient a model for one reason or another. So now we're kind of getting into the sketching portion of this where, um, so now we're getting into the sketching portion of this where we can see we built out a reference plane based off of that large object that we created. And now we're just coming in and pulling out some basic arcs and lines here. So with something like a rail, we could sketch this using arcs and lines. We could sketch it using splines. We could use a lot of different tools, but this was just a really quick and simple breakdown of how to go in and build out some basic geometry, very similar to the way that we would inside of SOLIDWORKS, where we're getting just rough sketch geometry, and then we'll trim all that together and manipulate it as we need to. All right, so you can see here now that we've got all these basic hard lines, we're just going to trim off all of the excess data. And one of the things that I found inside of Shaper when we're looking at it from a reverse engineering tool set is when we're dealing with parts that have lots of arcs and lines, I prefer to build out the just straight edges first, get that raw geometry. And then in the 3D aspect, we can pull those into our fillets and our, where we would normally have arcs. We can do that from the 3D section of the tool set. However, there are certain areas like on the top of this rail where maybe we want to put in a spline. And for those specific aspects, we'll go ahead and put a spline in first.
So you're using an Apple Pencil here, right, with the iPad?
Yeah, so this is using an Apple Pencil with the iPad. And that's really something that is pretty critical for this process. So, Shaper 3D isn't really intended to be a reverse engineering software. So with that, there's some fine tuning that you kind of need to do to be able to get a lot of your measurements from a visual standpoint. So for instance, you can see right here where I'm manipulating these arcs and lines, or these lines rather, the node points. We're really wanting to have some fine-tuned, or we really want to be able to pick the fine points relatively quickly for where we want to actually put those specific line nodes to, and something like an Apple Pencil is going to be a lot easier to use than trying to do that with your finger. And now you can see it's starting to make a little bit more sense as far as how we were doing our reverse engineering, where we have all of these lines that kind of block out what the part should be. And then in the 3D aspect, we're coming in and we're building out all of our fillets and just kind of pulling all of those curves together for our part. And then of course, for this one, I didn't choose to mirror the part. I went ahead and just sketched it on both sides. And then we're just going to repeat that process on the opposite side. If you mirrored it, it could save a little bit more time. However, in trying to understand a little bit more about how this software works and just get a little bit more time playing around with it, I chose not to mirror the parts at all and just decide to reverse engineer the part as is, as opposed to trying to make it as perfect to CAD as possible. And we can notice that a little bit on some of the slight deviations of the part. We can see where the rail bed's actually lower on the left-hand side of the part versus the right-hand side, and just a couple of small nuances that really are more true to the part that we created, as opposed to what a perfect CAD example would be, or the part that we scanned, rather than what a perfect CAD representation of this part would be. So from here, it's pretty straightforward to build out the rest of this part. We can copy and paste the two different aspects. So what was critical for us here was I wanted to get that one section of rail and then copy another section of rail that's slightly offset in relationship to the scan data, which we're able to do really quickly. And then we'll go ahead and just finish this off with going ahead and recreating these mailing structures. And that's going through just the same process of sketching out our lines, building out our profile, and then we'll go ahead and turn those into a solid object, clean them up with some fillets. And this time we will actually mirror that part to the other side of the rail. And you can see once we have that 2D sketch, we are just simply clicking and dragging it to pull it all the way out. And there are precise controls that we get inside of the software too. So you can see I made that exactly 36 inches long. And then once we had it at 36 inches, I could just move it left to right to get it centered to where the object should be. And then from there, we can go ahead and mirror that part over. And then we'll go ahead and trim out all the holes that we need to trim out on the where these bolt hole locations are. So doing something like this is really straightforward, where we can simply just find the center point of one of these holes, figure out what the diameter should be. So we're looking at about 3/4 of an inch for that particular hole position. We're just getting everything centered up here. And then once we have all of that figured out, we can simply just copy and paste our hole position across the rest of the hole locations, and then we can just cut them out with a extrude tool.
I could imagine that there will be some software updates potentially in Shaper or other apps that would allow a little bit more visibility and some more reverse engineering like features, so that creating off of a mesh would be a little bit closer to what we do on a computer. But besides those visual types of user interface features, this is already impressive to me in that you can import a large mesh and sketch a CAD model based off of it on an iPad.
Yeah, absolutely. So something like Shaper, it's not intended to be a reverse engineering software right now, right? But it's also something that's relatively new. I think it's only a year or so old, maybe 2 years old. So with that in mind, the tools that we have and the fact that we're doing this, the fact that we can get this far in a process using just an iPad is pretty impressive, right? Is it the most accurate software in the world for doing reverse engineering? No, we would need to be in something like Design X or a good SOLIDWORKS plugin to get real high precision in our measurements. However, with what we're doing right now, just the ability to very quickly and easily reverse engineer something like this without having to be sitting in front of a computer is pretty impressive, right? So it's something that I think shows a lot of promise and is really interesting to see as far as how we could take, or how far we were able to take this experiment to be able to actually go from a physical object all the way to a good CAD model without having to ever sit down in front of a traditional Windows computer to generate that. So from start to finish, we're able to do some pretty interesting things here.
All right, and that looks like your model is finished.
Yep. Yep, so that's pretty much the basics of the model right there. And then once we have something like this, we're actually going to go into another project, or there's a case study that we're doing specifically on railway inspection. So to give just a little bit of an alternate workflow, if we do go back to using a computer, I'm going to share another screen real quick with you, Art. So this is another section of a rail that we did the exact same process with. So we scanned it, uploaded it to the cloud, processed everything. The only difference is instead of downloading this onto an iPad, I went ahead and downloaded this onto my standard work computer and built out a rail section using SOLIDWORKS. So we did a more traditional rail section. This one I actually swept the curve of the known rail into. I think you can kind of see that there. So for this, the purpose of this particular process was to take our scan data, where we can see here. Yeah. So we've got our rail section that was scanned again with Leo. And we've got some various distortions. So whether they're engine burn distortions or just some fragmentation that's coming from wear over time, we've got these represented here in our STL mesh. And when we overlay our CAD model on top of that, we can do a real simple 3D comparison that shows how those distorted areas are being displaced on our part and how that's affecting the overall quality of this rail section. So we can see a little bit of an area right here. And we're just using Geomagic Control X right now to kind of show a change of pace. And you can do this inside of Artec Studio as well. But with this, I'll go ahead and actually increase the resolution here. So let's just change that up to maybe 25. Yep, and now we can see, say in this section, specific banding of how that distortion goes into place. And we get some really interesting analyses off of this rail as it would compare to a perfect CAD model of what that rail should be. So we can take this in a lot of different directions. I think there's a lot of promise for being able to use the Leo and the Artec Cloud in iPad apps in the future. And we're going to be playing around with some more to kind of get our thoughts on other interesting applications that are out there. But from a traditional workflow standpoint, you can see that it's just as easy to jump right back into one of your more standard inspection or reverse engineering softwares like Control X or Design X directly from the cloud and just starting your computer use at this particular point in the process. So I think that's pretty much it for this video. Is there anything else that you want to add to this, Art?
No, that's to me just impressive that we're able to use it in both an iPad and a computer, but also avoiding actually using a computer to process the scans themselves. So we kind of skip the processing step on your laptop and your iPad that happens in the cloud. When you're ready to work with the scan data, it's just available to you. So this is a really great showcase of that.
Awesome. All right. Well, we look forward to seeing you all in the next video.
Thanks for watching, everybody, and we hope this has been helpful.